Hello guys, welcome back. So in today's lesson we're gonna do machining of this geometry or 3D model. So this is gonna be fully explained. So let's get started. First of all, we're gonna do select our machine, but I already selected, but I will repeat. Go to machine tab, go to mill, and then go to select default. As I already selected, after selecting default, you're gonna see this toolpath over here. If you doesn't see this window of toolpath here, go to view section, and over here you can see, click over here toolpath, and then in the left side you're gonna similarly see the window as it's showing in my computer. So now we're gonna set up our stock. So go to stock, click over here, and then usually we do select our rectangular stock in most of our previous models. So but this is a cylindrical model shape, you can see. So we're gonna select our, click over here to cylindrical, and then for the axis, as it's z axis height, so we're gonna click on here on z axis. And now for the over here you can click on display the stock, and then for here, as you know in my previous lesson, if you watch how to select the stock, click on all solids, and then by clicking over here it's gonna automatically select our dimensions of the stock. So click OK, and then this red dotted line shows our stock is set up, and it shows in wireframe. If you want to see other way, you can click on solid and then click OK, and then you can see it says solid. You can see the more graphically better, but I'm gonna go back to wireframe. It's easy to work with wireframe. So click OK, and now our next step gonna be of machining it. So we gonna use dynamic mill. So for that, go to toolpaths, and here it comes the dynamic mill. If you doesn't see over here dynamic mill, you can click over here on expand gallery, and then you can see over here dynamic counter, dynamic mill. So today we're gonna fully explain dynamic mill. So let's go on dynamic mill. So then after clicking that, you're gonna see this chain option comes up, and this is the plays major role in selection. Like this is the base of our toolpath. So by here you're gonna start looking carefully, and I'm gonna explain everything. So first of all, it says machining region, so we need to select exactly where we want to do machining. So over here right now it says a 0 digit, it means we don't have any selected region. And then from here we're gonna select, and from here if we want to remove anything from, then click over here. So first we're gonna click on select, and then this chain gonna comes up, and then this is a wireframe selection. As you click over here for a second, then it's gonna show it says wireframe, and click over here it's gonna be solid. So alt 7 for the isometric view, alt 1 for the top view. So it's just a tip as I mentioned in previous videos. So now we are on a solid face. So these are different things. So click over here, it's gonna be edge, loop, like different things, but we're gonna do face. So click on here on face. So our face is selected. Now we're gonna select the face. We want to machine this region, so click over here, it's gonna select this region, and then click OK. As you can see over here, now it says 1, we have one chain selected. And this time from here, how you want to start the machining strategy, just in our this example we're gonna do from outside, because if we are doing circle milling, then we have to do from inside. But right now we want our tool to come from outside, so we're gonna click on from outside. And then over here we gonna don't need anything, we're gonna remain this is default. And then here comes the avoidance region. What avoidance region means is where you don't want toolpath to go. For example, I will click over here to preview first, and then you can see we're gonna machine this whole thing, but our toolpath is also coming in between this top portion which we don't want to machine. So how to avoid this? By selecting that region. For that I'm gonna go to avoidance region, select avoidance, and then just simply, or you can select the face of top, click OK, and then you can review the chain, review it. Now you can see it's avoiding that space. So it's just doing machining of this. So that's the purpose of avoidance region. And the A region is if you want to like tell Mastercam like where is the air region, like where you want there is nothing, it's like a free open, no point of intersection, they're gonna be like air region. We don't usually use much in these kind of simple examples. So entry chain gonna be like where you want to specifically start our toolpath, but we don't gonna use it over here, so we gonna ignore it. So just simply for now click OK. As you can see, then our dynamic mill window gonna comes up, and over here this is the same we did in the previous things, preview and all. And this over here you can see we have selected our dynamic mill. And now comes to the tool. So I already selected the 1/2 inch flat end mill tool. I previously explained in my previous video lessons how to select it, but over here I gonna again quickly show you. Just see, we're gonna use 1/2 inch. So click OK, select library tool, and then over here you're gonna see select 1/2 inch end mill. I already selected, but see it's again gonna show similar tool warning. I'm just gonna ignore it and delete our first tool. So by this our 1/2 inch flat end mill is selected. So over here comment roughing outer side, and over here you can change your feed and speeds. So go to cut. Next is holder, like which holder you want to, if you have any customized or specific, if it's hitting our part then you can customize it, use different holders. That's just example, but I gonna use the default one. So go to cut parameters, and then here comes the where we gonna explain most of our time. So it's dynamic mill, this whole window you can see. So for now I just gonna do remain default, and then depth cuts remain everything default. Then go to linking parameters, just simply click OK. I'm not gonna do anything, just leave everything default. It's gonna automatically generate a toolpath. First of all, I'm gonna hide the stock because it's like it's not graphically looking good. So how are you gonna hide this? As I mentioned before, click over here, display, hide, OK. So now it's look better. So now comes the, I'm gonna decrease this window. Now comes our main thing. As you can see over here, the blue line shows our machining region, and this green and yellow shows our entry and exit points. So right now you can see, if we see from Alt1 top view, it's entering from our by default left side. So again go to parameters, toolpath. If we want to change anything, we're gonna go to parameters, and now I'm gonna explain most of the thing. First of all, I'm gonna say that it says cutting method like climb or conventional. What climb means is, you can find this information on Google also, but I'm gonna just briefly explain. It means like the tool motion gonna be opposite of our tool direction. So like if it's going, our tool path is along clockwise direction, but our rotation gonna be anti-clockwise. Like our tool rotation GO3, it's gonna be MO3, MO4, like anti-clockwise. So that means, and then conventional means same. If it's our tool path and our rotation of tool gonna be in same direction. This is mostly for hard steel, like hard products, hard material, and climb is for normal, like most of the time we use climb mill, and it's for like good finishing. You can see we use climb mill. So now it goes to temp compensation. What does that mean is, it usually mean how you want. It's mostly used in ball and mills. It's like if you go to 4-axis 5-axis machining, there it plays a major role. But over here, as our end mill is usually flat, so we don't need any center mill. So you can see it shows our tip compensation gonna be from the center, but we want tip because our end mill is flat. Our selector tool is 1/2 inch flat end mill, so it's flat. And now comes the approach distance. What does that mean is how it gonna be, like it's the absolute distance from our part. Over here you can see the distance, this means the approach distance. For example, over here we don't have much approach distance. You can see if we change this value to 2 for example, and then click OK. Now we don't need to regenerate it. So how we gonna do is, so click over here, it's gonna regenerate the toolpath, and now you can see it started from 2 inch away from our part. So now you can start understanding what exactly approach distance means. So over here similarly with that, if you want to start from right, left, or whichever, like for right now it started from kind of a left, front left, but we want to change it to right. So if we say top right, click over here and then click, and now regenerate it, and now you can clearly see it's from the right direction of our tool. So hope you understand this. Now again go to parameters. Next is first pass offset. This means it gonna offset our first pass in x and y direction. For example, over here, that means you can see over here, like just remember this toolpath is look like that. It doesn't have any offset, like it's close to the distance of our part. So if you go on parameters and click on offsets, like it's a absolute distance. So if we want like 0.5, it's gonna be a lot, but just for example, if we do 0.5 in first pass offset, and this is the feed, like if we want to reduce the feed of the tool path in our first offset, we can do from here. Like if we want to 50%, we can make it little slow in our first pass to for a safe side. So click OK, and now you can see we regenerate it. You can see the offset clearly. You can see the offset over here, too many tool paths on the edge. It says the tool path because there are too many, because I left a 0.5 which is a big digit, half inch. So if we change it to like 0.25, click OK and regenerate it, now you can see it's gonna be at least half of it. So that, I hope you understand the meaning of first pass offset. And then here comes the conventional feed rate. It's mostly used in zigzag. As you can see, now we can use this value. So for climb we don't have any zigzags available. For like conventional available. For zigzag means the tool gonna, is you understand, it gonna go opposite of its first pass. That's the zigzag method means. So it's usually used in like facing kind of, you can understand if you want to go zigzag to save time. So it's the, we can select over here as a zigzag, but over here for now this example we're gonna use climb mill. So next come the step over. As you click over here, from here you can start understanding. It says after one pass, for like after one pass, for the second pass, how much it gonna be the distance over here. So it's right now it's the 0.20, like 25% of our tool, which is like our tool is half inch, so 25 gonna be 1/8 of our tool. So our step over is 1/8. So let's see if we want to increase it. Increasing in step over gonna lead to less tool paths. So let's say if we want to change it to 50%, and now you can see automatically it says 1/4 inch. So now this time after one pass, our tool gonna be moved 1/4 inch next tool path. So I will give example. Click OK, and now generate over here, and now you can see clearly over here it's a big distance between these two, because it's a 1/4 inch distance. How to verify it, I will try to show. If you go to home, select analyze toolpath, and then just simply select over here alt 1, this time is our X position is 1.8 and over here is 1.6. You can clearly see it's 0.25. If we add 0.25 over here, so it's gonna be estimately 0.89. So you can see the our step over distance, which is 0.25. So skip it, again go to parameters. So now I hope you understand these things, approach distance and step over everything. Now comes to our gap size. This is we use it much, but for basics we don't use much. It means like micro lift. For example, over here you can see over here it says how much a tool gonna lift after one pass, like to move to another pass. How much when it gonna lift is if our distance of another tool path is gonna be 100% of our tool diameter. For example, we have half-inch end mill. If our next tool path from our previous tool path is half-inch away, it gonna lift. So how much it gonna lift? It gonna lift 0.01. Why it gonna lift? To avoid the to avoid to get some to leave some space for the chips to go out, like small chips, and also to avoid overheating of the tool. So that usually micro lift distance means, so that's why it's have only 10,000. So it's very little value to get some room for the chips to go out. And similarly, this is the feed rate. So it's related to this, when it gonna go up and go to another tool path, so it gonna go by specifically this feed. I hope you are getting it. I know it's too much, but that's how are the basics of dynamic mill is. So for this I'm gonna avoid this is similarly to this thing, but just that's enough for the basics, I believe. And then go to stock. You know this very well. In my previous lessons I talk how much you want to leave stock. Like for now we don't need any floors, we know we're gonna be 0, and for our wall we need 3,000. So if for this I gonna explain more better. Click OK and regenerate it. If you go to verify tab over here, so this is our verify tab. Over here I gonna disable access for the better understanding, and then go to verify, click on color loop, and I'm just simply gonna start. So you can see it comes 2 inch away from our part as we selected in approach distance. I'm gonna make it a bit faster. So now you can see over here, if I enable wireframe view, home, go to wireframe, and then for the stock I'm gonna make it a little blurry. Yeah, so now if you disable the tool, over here you see our wireframe is over here, but it doesn't cut till our wireframe. It leaves some material, which is exactly 30,000 as we mentioned in our parameter over here. If we make it to 0 and then click OK, and now regenerate it, and now you're gonna see the change. Go to verify and start it again. Okay, now you're gonna see the change. Yes. And yeah, you can see over here it's clearly did its toolpath up for wireframe, which is exactly what we want. But in our case we don't want to do all the roughing, we want some material for the finishing. So we're gonna change back to 0.033,000, And then hope you understand this panel. And now we're gonna go to depth cuts. It's easy to understand as I explained in previous. It's all about depth cuts. First of all, in our this part, it's for now you can see it's just doing kind of doing it in one pass in z-axis. So by enabling this, it's gonna make more z-axis paths, cut paths. So for our next, this is max rough step, which means how much maximum you want to cut in z-axis simply. So right now we want like 0.25, for example. It's the half of our tool diameter. And then our finish cut, how much you want to do finish cuts, like one. How much you want to cut a finish cut, like 1/8, quarter of our tool diameter, which is. So now if you click OK, and now you can see the change. There gonna be more z-axis tool motion. This is our first, second, and now you can see over here we have 3 passes. By clicking on our front view, you can see it's have 3 passes. So which is and because of our depth cuts. So our first depth cut, it's the difference gonna be 0.25. Let me explain. If we go to analyze toolpath, then put z is over here is 0.1875, and then you can see it's difference, it's the 0.375 and then 0.5. So it's the differences of in between is 0.25 as we selected in our parameters in depth cuts. So that's all this mean in depth cuts. And for over here island depth, we are not doing any island. You can see, click over here, you can see over here this is all about island. Like if you have anything standing above you don't want to machine, so over here then we gonna use our island depth. But over here we not gonna use any island depths. So that's mostly about depth cuts in this lesson. Next gonna be our entry motion. So what this means is, it means like how you want the entry of a tool in our part, how you want to engage tool in our part. Like for example, it's helix, it's followed by full material blur or profile, medial, custom, plunge only. But for over here we not gonna use this, we gonna leave it default. Why? Because we gonna come from outside, so we don't need anything, so we just simply gonna leave it default. I will gonna explain you when I gonna do circle mill of this in the center, then I'm gonna explain you more about entry method. But for now we gonna leave this default. Then comes to breakthrough, where we use breakthrough. For example, if we have any through hole or through pocket or something slot, then we're gonna use breakthrough. But for now our maximum depth is up to this point, so we don't wanna use breakthrough, so we're gonna leave it as it is. We're not gonna activate it. Here comes the linking parameter. So this plays also important role. This is also another important things, where or up to where you want to select the tool or everything. So for now you can see this is default. How to change this? First of all, I'm gonna click OK, and then Alt T to hide the toolpath, Alt T to unhide. I'm gonna hide it, Alt T, and now Alt 7 to isometric view. Go to parameters, and now comes to linking parameters. So clearly if we see generate our toolpath, Alt T, first of all it's starting from 2 inch away, which we don't want right now. I just did for absolute distance, approach distance for example. And then you can see if we go to our front view, it started just from like, if you go to parameters, it just started 0.25 from our first toolpath. So if we want to change it, first of all I'm gonna go to parameters, make it 0, click OK and regenerate it. So now we don't gonna go too far, it's much better to understand. So now go to parameters, linking parameters, enable clearance 2 inch absolute. What does that mean is it gonna come and go, tool gonna come and go from this distance 2 inch above from top of our stock. So let me give you example. Click OK. Now if we generate our toolpath, and you can clearly see the yellow line shows the top, it's gonna be 2 inch from top of our stock, which is for a safety. So we're gonna enable it, enable retract feed plane depth, click on associate, and from here you can select the specific depth. Now click OK and then click OK over here. Now if you generate the toolpath, regenerate all the operations, and now you can see it gonna generate a toolpath. I'm gonna fast forward it little bit. So now you can see our toolpath is completed. Now simply click open here and then go to verify, and now we're gonna do verify it. So just gonna see over here, it's doing z-axis 0.25 every pass, and then it's gonna do one finish path as we mentioned in our depth cuts. So this gonna be our last depth cut, and now you can see over here it's result finishing. So I hope you understand the point of dynamic mill. Similarly, we're gonna dynamic mill this part. How we gonna do is we just simply gonna copy our this operation, and then we're gonna change our chaining strategy. So how we do it, just simply right click of mouse and keep pressing and drag it over here, then click over here to copy after, and then we're gonna move this arrow downward, click over here. So now go to geometry region, double click it, geometry, and now you're gonna see this option. So we're gonna rechain it all. So how we gonna do is just simply deselect first all if anything is selected. Now we're gonna select it as I mentioned before. For solid face, this thing, click OK. From outside is enabled, good. Avoidance region, click OK. This time we're gonna avoid this region, click OK. Preview chain, and now you can see our geometry, and now click OK. And now again go back to parameters, we need to change our depth values. So for over here deselect, and then again select our bottom chain, click OK. This indicates our maximum depth gonna be at this point. We don't want to go more than that depth because we have this solid. And now regenerate it, regenerate all solids, and then it's gonna regenerate its toolpath. This is our first operation, and now you started seeing our second operation. Why it's taking too many passes? Because we have also enabled z-axis in z depth, and then it's taking more passes in xy direction also because we had offset. So I just quickly gonna change it. So cut parameters over here to 0 and everything 0, click OK, and then similarly in the parameters of our second operation 0, click OK. And now if we do regenerate, you can see the clearly difference. It's gonna be not much passes in xy direction, and it's showing more passes in z direction because of our z depth value. So that's guys, for this tutorial I'm not gonna do finishing of this and circle milling. I want you guys to do by yourself, because I'm gonna attach a link where you can download this CAD file and then you can practice by yourselves. I have lots of tutorials on how to do finishing and circle milling specifically, so you can take help from those tutorials and then give it a try. If you still need any help, you can comment below in this video lesson and we will reach you out. Thanks for watching, guys. If you found this tutorial helpful, please hit like and comment and share with your friends. Thanks for watching, guys. See you in next tutorial.